In this lesson we're going to examine polynomials. At the end you should know how are polynomials classified as well as how to add and subtract them. So let's establish what a polynomial is. Its specific form looks like what you see on your screen, but I'll admit this can be overwhelming when you're first learning about polynomials. So let's break it down. In order to understand what a polynomial is, let's first talk about a monomial. So polynomial is a general category, and a monomial is a specific type of a polynomial. So monomial is either an expression that's either a number, a variable, or it could be a product of a number and one or more variables. The exponents must be whole numbers. So let's see if you understand that. Is 10 an example of a monomial, or would this be a non-example? Well, since it's just a regular number, this would be an example. 4x is a product of a number and a variable, so this is also an example. Now 4 plus xy is a non-example because it's a sum. This would actually be what we call a binomial in a second, so it is two monomials. This one here, 0.5 ab squared, this is an example. It's a product of a number and multiple variables, and the exponents on those variables are whole numbers. Now, x to the negative first power would be a non-example because the exponent is not a whole number. 7 to the nth power is also a non-example because the exponent is a variable. This is actually exponential. All right, negative 3.6 h to the 12th. This would be an example. 2 over n would be a non-example specifically because this would be equivalent to 2n to the negative first power. So that would be a non-whole number as an exponent, or you can just remember you can't have your variables down in the denominator. So now that you've established what a monomial is, it's easiest to define a polynomial as it's either a monomial or a sum of monomials. So here's an example, 4x squared plus 10x minus 5. So that's 3 monomials put together with addition. Or technically you could look at it as addition or subtraction. The prefix poly means many. Nomial is up for debate what that means. My brain thinks garden gnomes, so many gnomes. Alright, now, a polynomial with two terms, think of a bike. A bike has 2 wheels, so a polynomial with 2 wheels would be a binomial. So take a guess what a polynomial with 3 terms is called. This would be a trinomial. And there are examples of both types on your screen. Okay. It's important to know when a polynomial is simplified, and it is when there are no like terms or parentheses remaining, because you'll be required to do that. Let's talk about another vocab word, the degree. The degree, if you kind of think of how hot is something, the degree refers to the exponent. So the degree of a monomial is the sum of the degrees of its variables. So when you look at your screen, 3a squared b cubed c, the variables would be 2, 3, and 1. So the degree would be, add those together to get a degree of 6. But when I'm talking about the degree of a polynomial, it would be the largest of the degrees of its terms. So, in this next one, 4x cubed plus 2xy plus 5xy cubed, I already put on the screen that the degree is 4, and I want you to look at why. So you look at this first term, the degree here is 3. The degree here is 2 because it has an exponent of 1 and 1. You add those together. So you look at each separate monomial. This would be 1 and 3 add together to give you a degree of 4 on that monomial. Then you don't add all of them together, you take the greatest one, which makes it 4. In letter B, the degree on each term, here it would be 3, here it would be 4, and here it would be 5. So the greatest of these would be 5. Alright, so let's see if you understand. Let's see if something is a polynomial, and if it is, we're going to state the degree, and we're going to classify it by its type. So negative 9, that's yes. The degree would be 0 because it doesn't have a variable at all, and it only has one term, so it's a monomial. The second one, check out your variables. Their exponents are all good. So this is yes. The greatest of the degrees of the monomials is 2, and it would be a trinomial because there are 3 terms. The next one, this one is no because of 12 to the nth power. That's not okay. You can't have a variable as an exponent. So I don't bother to classify it any further. The next one is also no because it has a negative exponent, so I'm not going to classify that or state its degree. The final one, check out your exponents. They're good. This is yes. Now, the degree. On the first term, 2xy squared, the degree there would be 3. xy, the degree would be 2. So the greatest one is 3, and it's a binomial because there are 2 terms. Now let's talk about standard form. Standard form of a polynomial is when you put the greatest degree first, and then your degrees decrease. So if I were to rewrite this with the x cubed term first, that term is negative x cubed plus 5x squared minus 4. And sometimes students struggle with getting their signs correct on their terms. So one of the tricks I've always done is when I do negative x cubed, I kind of put the sign in front of it with it. So this would be negative x cubed first. That's a positive 5x squared, so I put plus, and then it's negative 4, so it's minus 4 when you write it. Now, the leading coefficient is the coefficient that's now leading once it's in standard form. If it's not in standard form, it would be the coefficient on the term with the highest degree. So in this case, the coefficient is negative 1. The constant term is your plain old number, that is negative 4. And the next one is a binomial. We need to put this into standard form. The 3x squared term would come first, and it's positive 2, so plus 2. The leading coefficient is 3, and the constant term is positive 2. Now, let's get into addition and subtraction. Addition is the easier of the cases. When you add and subtract, all you're doing is combining like terms, so the variable part has to be identical. So when you're adding, letter A, I have a trinomial plus another trinomial. All I'm doing is I'm grouping my like terms together, and I can almost ignore the parentheses and just look for my like terms. So I start with my highest degree. I have a 2x cubed here, plus x cubed here would be 4x cubed. So combine your coefficients, keep your variables. Then I do the x squareds, because I go by decreasing degree. So I have a negative 5x squared. This would be plus 2x squared, would be negative 3x squared. Then I go for the x to the first power, which would be right here, plus x, and nothing else matches, so I just put plus x, and look for my constant minus 1. So that produces a polynomial with degree of degree 3. Okay, letter B. Again, it's addition, so I'm just looking for my like terms. My greatest degree is 3x squared plus x squared would be 4x squared. Then I have a positive x plus 4x would be plus 5x, and then my constants, negative 6 plus 10 would be a positive 4. That produces a trinomial with degree 2. The leading coefficient is 4, and the constant is also 4. I want to show you a vertical format for adding polynomials. Sometimes it's easier, and you can use this at any time. I just like it when you have a lot of things. If you line up your terms that are like with one another, then you can easily just add your coefficients. So I have, if I add the x's, 5 plus 7 is 12, minus 2 would be 10x. Notice that my variables are in alphabetical order with the constant last. That's something that we kind of do with polynomials. Go on to your y's. This would be 1y right here. So add my coefficients. 2 plus 1 is 3, minus 5 is negative 2y. Add your z's. Again, the coefficient here is 1, so negative 1 plus negative 3 would be negative 4, plus 4 would be 0. So I could put plus 0z, but that means it's not even there. So normally, I just don't even write it. Now my constants, 2 plus 3 is 5, minus 1 is 4. So it's positive 4, so I put plus 4. So this produces a trinomial. Now, with subtraction, if there's anywhere that students make a mistake, it's usually right here. I just want to remind you of something. So with polynomials, or with regular numbers, when you were taught 4 minus 10, at some point you were taught that this is equivalent to 4 plus negative 10, giving you negative 6. So you were taught to keep your first number, change your subtraction to addition, and change your sign on the second value. So using this same idea, what I'm going to do is change this to addition, and then I change the sign on everything in the second trinomial. So this becomes a positive, this one becomes negative, and this one becomes positive. Now, I'm going to rewrite both polynomials so that I don't have scribbled out signs. So 4n squared plus 5 plus 2n squared minus 2n plus 4. So we've rewritten everything, and now I'm going to identify my like terms. So I have 4n squared plus 2n squared would be 6n squared. Now, decreasing degree of the variable would be negative 2n first. There's nothing like with that. And then I have positive 4, or positive 5 plus 4 would be positive 9. So this produces a trinomial, degree 2, leading coefficient is 6, constant is positive 9. So again, letter B, I have a trinomial minus another trinomial. So I start by changing it to addition, and I change the sign on all three terms in the second polynomial, producing, again, I'm going to rewrite this, it's 4x squared minus 3x plus 5. Now plus negative 3x squared, I'm just going to write that as minus 3x squared, it's equivalent, plus x plus 8. Identify like terms. I have a 4x squared minus 3x squared would be 1x squared. Negative 3x plus x would be negative 2x. 5 plus 8 would be 13. So x squared minus 2x plus 13 is my final answer. It's a trinomial. Degree 2, leading coefficient 1, constant 13. It is simplified because there's no like terms or parentheses remaining. Finally, just a vertical format, a different way you can line up your polynomials. If you have a trinomial minus a trinomial, first of all, I need to change my subtraction to addition, and then I change the sign on every single term in the second one. And now they're lined up nicely, vertically, the ones that are like terms. So 5 plus 4 would be 9x squared. Negative 2xy plus 2xy, they would cancel, it would be 0. 2y squared minus 3y squared would be minus 1y squared. So this produces a binomial, degree 2, leading coefficient of 9.